Thought it was over, huh? Yeah, so did I. But I kind of forgot to do the one most important thing in the last video. I didn't play test the ROM. I mean, of course I didn't, you know, it was kind of an hour of programming, kind of wanted a break, and OBS doesn't let you append videos from what I can tell. Anyway, yeah, I was hoping it would just work and that'd be the end of it, but of course not. Of course, if you take a look-see here, a bunch of problems snuck through. So, let's just get to those. Okay, first issue. While everything does seem to be okay, what happens when Sonic hits a ramp? A steep ramp. Ah, come on. Alright, you see that? There's a number, and it's kind of just clipped into Sonic's back. And we can, you know, pause and unpause more and find more frames with this issue. Of course, you know, that ain't gonna work out for me now. Whatever, you can see them. Oh, that one was really bad. Let's see if I can get that one. Alright, well anyway, let's try and hear. Oh, that's more like it. So you see the issue. Now, let's pop open the VRAM editor to understand why this is happening. Okay, so this is the Mega Drive's video RAM, where all the tiles are kept. If you look here in the bottom left, I know you need a magnifying glass to see this, but you can see Sonic's tiles. And they take up this room here, and then right after it are these numbers. Now in-game they're usually yellow, but with Sonic's colour palette they're red. These are the points you get when you bust open an enemy. So it would appear that Sonic 3's sprites are a little too big for VRAM. And the solution is a long, drawn-out and complicated one. So this might not actually be the best issue to start with, really. So let's just keep this in mind. Sonic's sprite work is too big for Sonic 1. What can we do? We'll get to that. But for now, how about a more pressing and kind of simple issue? Let's just stand still. Nothing can go wrong there, right? I mean, come on. Looks good. It doesn't look so good. So, I made a bit of a mistake in the last video. You see, I suggested converting the mappings and DPLCs with SonMapEd. Here's the thing, it's kind of not very good. SonMapEd is really primitive when it comes to detecting the end of a mapping file. It's complicated, you don't just check the end of the file, it's different. But either way, yeah, it uses a really dumb way. And it causes it to chop off the last few frames of animation. So the last frame of the waiting animation isn't converted, it's garbage data. So we need to fix that. How? Well, I don't recommend using SonMapEd. Instead, I recommend Main Memory's MappingsConverter. This one does such a much better job. Also, when it comes to DPLCs, the thing that loads the graphics to VRAM, this is better because it avoids another issue with SonMapEd, where it kind of... well, the point of a DPLC is to efficiently load only the graphics you need for that sprite, right? SonMapEd kind of undoes it and like duplicates the art that gets loaded. I don't know how or why, but the point is, it will expand the amount of art loaded to VRAM, causing, well, what we saw earlier. So there are multiple reasons potentially. I'm not sure if this applies to Sonic, yes, to the Sonic 3 sprites, but I know it used to apply to the elemental shields back when I did those videos. So we're going to reconvert the mappings and DPLCs. So as you can see, it's simple enough. Just say binary. Pretty sure the Sonic 3 Disassembly uses binary. I'm going to convert to ASM for Sonic 1. Let's do some browsing. Oh no, they're ASM. So Just in case you don't know the drill, I suppose. So you want to ignore this. This is one from Sonic 3 alone. This is one from Sonic and Knuckles, and Sonic 3 and Knuckles. So you want that. You want to output it to Sonic.asm, and so on. Then you want to use DPLC converter, set it up again. And then you want Sonic pattern load cues. And you want that to replace Sonic dynamic GFX script. Now, I've already gone ahead and done this myself, hence these new scripts, so yeah. So again, the point is, this tool is better. It does not mutilate the mappings or the DPLCs. It does what it says on the tin. It converts them. It doesn't mess with them at all. So we're going to address our first, technically second issue by just, yeah, reconverting our script, our mappings. It is a damn shame though. Like, it's all the more reason for me to not recommend the tools I use in these damn videos. I imagine Flex is better, but I am not learning Flex. I'm sorry. I'm the one teaching you. Alright, so we should now be good to build, and it should work, and yeah, we'll see. One of these days I'll find out what the fast forward button on this emulator is. And there we go. So that is the simple issue addressed. So let's check that off our little to-do list. Okay, here we go. So just, yeah, set that one aside. That's dealt with. So now we have these remaining issues. Okay, how about another easy one before we get to the main, oh geez, main thing. Okay. Actually, I'll get back to you when I'm done setting this up. Okay, so yeah. So as you can see, there is a bit of an issue so far. So for some reason, Sonic just idles in his walking animation. Of course, I don't know the answer to this one. Remember how we couldn't use the Sonic animation script that uses frame IDs because the frame IDs are now totally invalid? Well, the animation scripts aren't the only place to use these invalid frame IDs. In fact, I think it might be for the best if we remove them entirely. Now, where are they kept? I think they're kept in constants.asm, so we're just going to look up fr_. Yeah, we just nuke them, right? They don't work anymore. I know you could technically go through and update them, but yuck. And oh dear, errors. Oh no. Okay, that's not what I was hoping for, but yeah, we can get to that. So here's an issue I couldn't demonstrate anywhere. Why do I keep jumping back and forth? In Sonic 1, if you duck, your hitbox gets shorter. This is useful for one area in Labyrinth Zone where I usually just end up ducking underneath an Asteron? An Asteron's projectiles. Yeah, that doesn't work anymore because it uses a hard-coded frame ID. So we're going to fix that, and we're actually going to change the logic a bit. In Sonic 1, when you duck, it's one frame, so the code works fine. But in Sonic 2 and 3, ducking has 2 frames, and in Sonic 2, only the second frame actually lowers your height. And it doesn't work for Tails at all, because he has his own frames. So we're going to just completely redo this. So instead of frame duck, we're going to change, I think it's called ID duck. And we're not going to check his sprite frame, we're going to check his animation. And that way, when Sonic ducks, regardless which ducking frame he's on, he will have a reduced hitbox. And yeah, it worked. So maybe wonder why I deleted the frames. Well, this is a slightly older disassembly. But if you take the newest Git disassembly and follow these instructions, you will still have a build error. Because there's one other place in the game that checks a hard-coded frame of Sonic's animation. And it's in sonic.asm. So we're going to look for, I think, end load? No, this isn't it. I think it's end move, actually. Here we go. End move Sonic. Now we just scroll down, and you'll find this line. Of course, it'll look a bit different for you because it won't be using a raw number. It'll be using one of those FR thingies. But again, it's just right above end move Sonic 3. And it sets Sonic's frame ID to his third one. Now, of course, what's the third frame in Sonic 1 is not the third frame in Sonic 3. So we're going to have to find out what frame to use. If you play Sonic 1 and look, the frame Sonic uses in Sonic 1 is like that. It's the waiting animation, but it's like the frame where he's got angry eyes and whatever. So we're going to want the Sonic 3 version of that. And I actually can't remember off the top of my head, so let's just take a peek at SonMapEd again. The one time it's going to be useful in this video. And unlike Sonic 1, where that frame's at the beginning, in Sonic 3 it's all the way at the end. I think it's BB or something. Here we go. It's this. It's the Sonic 1 version of this. No. Sorry. The Sonic 1 version of this. The angry frame. So BD. Now, so we just come in here and change it to BD. And if we build the ROM and test it, the engine should work now. Alright, that's good. And yeah, I've already checked the good ending as well. That works fine as well. So yeah. So that's another issue off the list, or two. Okie doke, let's get rid of that. Okay, another issue. I'm actually kind of stupid for not noticing this one. So I'm going to go to Starlight to show you what I mean. Alright, hopefully this captures it. So check this out. Oh, come on. So you see how he kind of just jitters between his horizontal walking animation and then his diagonal one? That's not a quirk of the game engine. Yeah, ignoring the corrupted sprites. It's yeah, that's a bug we introduced. So what's the issue? Well, if you look in SonMapEd and take a look at Sonic's running or walking animations, you'll see here's the horizontal one. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. And there's 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And so on. So Sonic's walking animation is 8 frames long. Meanwhile, his running animation is 4 frames long. Now the problem is, in Sonic 1, while his running animation is 4 frames, his walking animation is only 6. And this causes an issue. Now, without showing you any code, I'm just going to explain how the game figures out how to rotate Sonic. He has an angle variable, and then it uses it to calculate, if his angle is greater than, I don't know, 35, it'll kind of transform that into the number 6, and it will add that number to his current animation frame. So if he's at this frame, adding 6 will put him at this one. in Sonic 1. But, of course, that doesn't work when he has 8 of them. So if he's here, and you add 6, 1, 2, 3, 4, 5, 6, oh look, it's still horizontal, it's not diagonal. To get that, you need to add 8. So, I'm going to correct that now. The logic for this is in Sonic Animate. This is also an issue if you port the Sonic 2 sprite, because Sonic 2 has a longer running animation as well. Now, this code is so gross and so hard to follow. So you might notice this code right here. If animation is walk, run, roll, jump, branch. So we want this code. Okay. And if you try and follow it, you might notice this bit right here. Yeah, I think I know what's going on here. Ah man, this code's hard to follow. So if Sonic's running, we skip this logic. So D0, register D0, is Sonic's angle transformed to either 0, 2, 4, or 6. Like I said about how it transforms the angle from, say, 35 to 8, this is like a step before that. It transforms it into 0 for horizontal, 2 for diagonal, 4 for like 90 degrees, and 6 for the other 45 degrees. So it then gets multiplied by 2 right here by adding it to itself, and then it's added to Sonic's frame ID. So 2 becomes 4, which makes sense for the running animation. If you're walking, however, it does some extra calculations. It takes the 0, 2, or 4, divides it by 2, then adds it to its earlier self. So on top of it later being doubled, so 2 becomes 4, before that, it gets halved and then added to itself, or its earlier self. So 2 will become 1, and then that 1 will get added to 2, thus becoming 3. So then when we come here, 3 becomes 6. You see? So we need to change this logic. Rather than halving the number and then adding it to its unhalved self, we just add it to itself. So 2 becomes 4, and then here, 4 becomes 8. Simple. So, just do this. And there you go, problem solved. But of course, just to be sure, we're going to play test it real quick. Alright, so now, would you look at that? Works perfectly? Question mark. I mean, obviously I can't test every angle, but this one seems to be doing good, as is this one. For what little time I can test it. Yeah, okay, we've fixed diagonal animations. It really is just weird and annoying how many little issues come out when you change something. The kind of stuff you're only going to know about if you either play test a bunch or you just happen to know beforehand. And the silly thing is, I knew about this beforehand and I just forgot. So, do I need to explain to you how to edit the palette again? I mean, I guess I can try and tell you where... Ah, heck. I guess I can try and tell you what files to edit, but to be fair, even I don't know. I can give you a guess. If you want to correct the special stage and the continue palette, I imagine there's a special stage palette in here. Yeah, these maybe. Not sure where the continue one is though. Where the heck? Nah, I guess there's. Just go through them. Just go through all of them. You'll find it. Alright. Of note, we did change Sonic's colour, but we never changed his underwater colours. I think they actually look fine as they are, so I'm not going to bother editing those. Because if I recall, sometimes it's just kind of arbitrary. There's no arbitrary colour change that applies to every single colour. It's just like, oh, this one colour has become more green, or this colour's a little more blue, and so on. So... like I said, it looks fine. We don't have to worry about Sonic's underwater colour. That's not an issue. So, moving on from the palette issue that we're just going to pretend we fixed. Here's the hard one. Yep, I thought this was going to be easy. I thought it was just going to be converting the tiles, mappings, DPLCs, and animations. Heck no. Because Sonic 3 uses way more VRAM than Sonic 1. So, here's Green Hill. Here's the VRAM. where the game loads all the graphics, and as you can see, here's Sonic doing his little animation. Of course, you know, again, graphics made out of tiles, so this is what it actually looks like. They're just jigsaw pieced together to give you this. So, as you can see, Sonic is doing fine now, and he has this much room. I wish I could zoom in on this more, but yeah. And then right after his RAM, VRAM, are these points. So you bust open a badnik, they will drop those points. Yeah. So, Buzz Bomber, there you go, 100 points. Yeah. So the issue becomes when you run up a slope or something, anything that makes Sonic rotate. You start to notice these ugly, choppy sprites. And why? Because if we check VRAM, look at that, Sonic's used up all of his VRAM, and he can't fill up anymore, so these points get displayed instead. So let's ignore some of the more technical issues for now, and let's just ask ourselves, alright, we need to give Sonic this VRAM because he clearly needs it. We could just delete the point graphics, and a lot of hacks do that, and I hate it, but yeah, we could just move it. Now, as you can see, the VRAM is quite packed, but there are actually quite a few free areas we can move the points to. Now, I believe the points require 9 tiles. And if you look around, there are some gaps that do look like they're around 9 tiles. So we have this gap here, we have this gap here, this one, and this one. Now, I believe this one's only 8 tiles, so we can't use that. This one also appears to be unused. I'm not sure if this one's unused. It could be used by whatever the heck this scroll table thingy is. I don't know. I settled on the one next to the score, the HUD graphics. It is unused. I've done a full playthrough, and it doesn't appear to be used by anything. Not during regular gameplay, anyway. So it's free for the taking. So how do we move graphics in VRAM? Well, I think we should start by looking at where the game loads graphics. This is in the ink folder, pattern load queues. Again, if you don't remember from the last video, pattern is like Sega's own name for a tile. And we have many of these things, ones for each level, some for just random arbitrary things. If we come to main, which is just the standard one that's loaded everywhere in the main game, we can see the HUD, the rings, and the points. So as you can imagine, this is where the points currently are, and this is where the HUD is. Now you might be wondering, what the heck do these numbers mean? That is the wrong button. Yeah, what do these numbers mean? Well, yeah, this disassembly is kind of jank. But you see, this is... oh man, I hate explaining this. Okay, look. If you come here, you can count. So this is tile 0, this is tile 1, this is tile 2, 3, 4, and it just goes on until I think 800 in hexadecimal. Yeah. Well, this ain't those. These are, again, tile indexes, but multiplied by 32 in decimal, and 20 in hexadecimal. So if we take this and divide it by hexadecimal 20, we'll have the hexadecimal tile index. So 1 would be 20. Okay? Right, so to save you some grief in calculating this nonsense, the HUD, as you can see, starts well into this line, but we want to move the points to the start of this line. And it just so happens like the start of the line is like rounded to 100 or something, or maybe 800, I don't know, 200 probably, I don't know. So, if we want to turn this number from where the HUD is to the start of the line the HUD is, well, it's D800, we just kind of round it down. So we're going to change the points from whatever the hell this is to D800. Now if we build the ROM and look at VRAM, the points will be here now. But when you bust open an enemy, they won't show any points at all. That's because it's all well and good that we've changed where the graphics are being loaded, but the rest of the game doesn't know where to get the graphics from. Yeah, it's not centralized. There's not one number, there's two. Where is this number? Well, the points have their own object. I can't be asked to find it. I'm going to show you a cool cheat. So, whenever you change a VRAM address like this, and you need to synchronize everything that used to use the old address, we just search for the address in sonic.lst, which again is just a big blob of all the code in the ROM combined together. Man, this tanks the performance. But yeah, all of the code in the game. So if you just come here, take the old location and search for that, will we find it? No. Okay, yeah, but no. That's not it. That's not it. That's not it. I think we just wrapped around to the top. Here we did. So what's going on? Why can't we find it? Well, here's the thing. There are multiple ways to reference a section of VRAM. You have the tile index, 0, 1, 2, 3, 4. You have tile address, which is like 0, 20, 40, 60, 80. And there's also a third way, referring to it as the 20 thing, but divided by 2, so in tens, so 0, 10, 20, 30. So while the pattern load queues in this disassembly use the tile address, the code uses the tile index. So we need to divide this by 20 in hexadecimal. So let's bust out the calculator for this one, because I cannot do hexadecimal mathematics. Pop it in here, divide it by 20, 797. So we're just going to look for 797. And hopefully we'll find what we're looking for. Now we're going to get a lot of false results from numbers like this. Ah, perfect. Right here, we found it. I know there's a 2 at the beginning, ignore that. That's not related to the tile index, but as you can see, we found object 29, the points object, and it sets the place to read graphics from VRAM to 797. If we continue looking for 797, I don't think we'll find anything else. So we might be at this for a while. How many 797s are there? 28. Alright, we can do that. Yeah, so you see, this is all that matters. There's the only one that's important. So we need to change it from whatever divided by 20 to D800 divided by 20. So I'll put that back in here, divided by 20. 6CO. And it's object 29, I think. I've already forgotten. So 29 points. Open that in Notepad++. And there we go. So if we quickly build the ROM, bust open a badnik, we should have the points appear just fine, despite them being relocated in VRAM. Alright, so here's Green Hill, here's VRAM, and would you look at that, the points have been moved, they're now over here. But does the game continue to use them properly? Yes, it does. Okay, that's that dealt with. So we've now freed up the space next to Sonic's VRAM so he can use it, but he won't use it. Like, if you want to know what happens when you show a glitchy sprite, it won't show the number 100 anymore. Sonic will just be missing chunks of his own body, which is not much of an improvement. So, this is where the bulk of the video is going to be. We're already half an hour in and we're not even close to the end. So, I was really hoping it wouldn't become this complex, but... well, where do I begin? Sonic has a limit on how big his sprite work can be. I know he just freed up some VRAM, but that's not the only thing in the game that does anything like that. No, you see, Sonic 1, and only Sonic 1, maybe Sonic CD as well, But Sonic 2 and 3 don't have this issue. Sonic 1 chooses a really weird way of loading Sonic's graphics. I know this is really low level stuff that you probably don't understand, but let me just try and illustrate it. So here is load GFX, the thing that loads Sonic's graphics. Now, if you check what this code does, it reads the mappings and the DPLCs, or just the DPLCs, sorry. It doesn't write them to VRAM. What this does is read it from ROM to regular RAM. But the Mega Drive can't display graphics that are in RAM. What's going on here? Well, it writes the graphics to this buffer. This buffer has nothing to do with VRAM, and it has its own size limit. What the game does is it'll read the graphics from ROM to RAM, then later it'll perform what we call a DMA transfer from RAM to VRAM. There's probably a technical reason for this. Apparently older Mega Drive cartridges you couldn't DMA from ROM to VRAM. Yeah, it's complicated, but apparently just Sonic 1 had to do this, and it's gross. So you might be thinking, why not just make this buffer bigger? Well, while the VRAM in Sonic 1 has a lot of empty space, Sonic 1's regular RAM doesn't quite have that luxury. I know, if you look around a little, you'll find some free RAM, like there's 40 bytes of free RAM right here. There's technically 80 bytes of free RAM here, but it's actually used, so no. And as you can see, we have 2 EO bytes. Now, in order to support Sonic 3's full set of tiles, I think we need around 400 bytes, and we just don't have that. We cannot make this buffer bigger. So, remember how I said in Sonic 2 and 3 they don't do this at all? We're going to have to go through the technical nightmare, unfortunately, of doing what Sonic 2 and 3 did. Yeah. So, like, do you know how to do a DMA transfer? Most likely not. Luckily, you don't have to. I mean, we ported Sonic 3's sprites. Who's to say we can't port Sonic 2's code? Now, of course, if you've seen my Elemental Shields video, we did this before, and we didn't use code from Sonic 2. We used a DMA queue made by Flamewing, the guy that made Classic Heroes. And yeah, that worked for the Elemental Shields, but it won't work here, because you see, I didn't think we were going to need his DMA queue. So if you take a peek, let me illustrate this better. Okay, I can't, but look right here. ASM68K. This is like the plain Sonic 1 disassembly. And we can't use Flamewing's stuff with it because it's incompatible. You need a special version. You need this one, the AS version. And I'm not about to just convert the whole disassembly to AS. So we're using this version, which for complicated reasons means we can't use Flamewing's DMA queue. So we're going to do something a bit different. Yeah, we're going to port the DMA queue from Sonic 2. Now, what's a DMA queue? It's complicated. It's essentially just a thing that loads graphics to VRAM for you. Okay? So we're going to port that from Sonic 2. Now, I've got it right over here. One sec. Yeah, got it right over here. And the code we want is in Sonic 2, S2.asm. We're going to look up QDMA. And as you can see, we have QDMA transfer. And it's a lot of heebie-jeebie spooky code, but we don't need to worry about that. We just need to copy it. So, we want, QDMA transfer and process DMA queue. So just highlight it and copy it. And the code is almost completely compatible with Sonic 1. There is one change we have to do, but it's not that bad. So going back to Sonic.asm, we're just going to put this in the same place Sonic 2 put it, which is right above the Nemesis decompressor. So we're going to come here and look for Nemdeck. Okay, don't want to look up Nemesis. Here we go. So we're going to put our Sonic 2 code right here. Now, if we build it, we're going to get an error about this line right here. Remember how I said Flamewing's code doesn't work with the Sonic 1 disassembly by default? It's because it does stuff like this, which you just cannot do in this disassembly because of the assembler. So what we can do is take this Sonic 2 disassembly, build it. This is going to take a while because it's slow as hell. And that will give us s2.lst. You know, that thing where the whole file is, yeah, processed and dumped here. So now we're going to look up that line of code that we're going to have trouble with. So it's right above QDMA transfer done. Look that up. And I know this is complicated nonsense, but basically this code becomes this number. So just copy that, come back to Sonic 1, replace this weird thing with this number, get rid of the gap, give it the hexadecimal symbol, and there you go. Now it will build properly. Or not. Oh, yeah, sorry. It will build, but it uses two new variables. We have VDP command buffer and VDP command buffer slot. Now, if we take a look at Sonic 2's RAM, which you can find right here, you can find these variables. There's just stuff I cannot explain in these videos because they're such big, complicated topics. But as you can see, the Sonic 1 and 2 disassemblers have totally different ways of defining their RAM. These are just hard-coded addresses, so you say the location of each variable. The Sonic 2 disassembly does the complete opposite. Instead of a location, it says the size. So this will be put 300 bytes after this, because this is 300 bytes long, and then 300 after that, and whatever this number is, and so on. Yeah, it's very annoying to convert between the two. So we just want these two. Where we put them does not matter. Well, I mean, we don't have to put it in the same place as Sonic 2. It doesn't matter where we put it. So we're just going to copy them. And we're going to put them where this big buffer is, because we're going to get rid of it, you know? We ain't going to load Sonic's graphics to RAM anymore. That's stupid. So... man. Okay, so of course this first thing will go where the array begins, and this needs to go after it. So you can do this. We're timesing it by 2 because this is measured in bytes, but right here it's doing it in words, which is 2 bytes. Yeah, it's all complicated rubbish. Just this works, okay? So now if we build the ROM, it'll do so successfully, but it won't fix our problem. We aren't actually using this DMAQ thingy yet. No, to do that we're going to have to hook it into a whole bunch of code. You see, we have QDMA, which is used for loading graphics, and we aren't loading any graphics yet, so we don't have to worry about that just yet. What we want to worry about is process DMAQ. You see, what you do is a queue. You know, you get in line and you wait, and something will run through the queue and process it, right? So you call this once, and then the data just waits. The data waits for the game itself to run this. And when this gets ran, it'll look through the queue and deal with it. So if we queue stuff, it's pointless if we don't process it. So we need to look through Sonic 2 and find out where it calls process DMAQ and then add them to Sonic 1. Now I already know. They're called in it's called in what is called, haha, vin. This is complicated stuff that I can't explain for you. All you need to know is it's code that's ran once per frame. So, once per frame, it calls process DMAQ. And the reason there are so many of them isn't because it calls process DMAQ multiple times a frame. No. It's because this is different code for different modes that gets ran once per frame. So if you're in the ending, vint will run the vint ending code. If the game is fading the screen, it'll call the vint fade code, and so on. And that's because, well, if you can see, fading doesn't call process DMA-Q because the game doesn't do any DMA transfers during fading. It does do DMA transfers during the ending, and so on. Now, we're only going to be modifying... Yeah, only Sonic will be using this DMA transfer thingy. So we only need to add process DMA-Q to the modes that Sonic would normally be in. Or be changing his art in. Yeah, it's complicated. So let's go to... I think this disassembly calls it VBlank, which is kind of stupid. Yeah, here we go. And oh boy. So while the Sonic 2 disassembly was kind enough to tell you what each one was, the Sonic 1 disassembly just gives you a bunch of numbers. Now, I've already gone and done all of this as practice. So for whatever reason, you only need to add it to VBlank 0, the standard gameplay one. I don't know what any of these are, but they don't need a DMA-Q, the process DMA-Q thing, for some reason. Ah, no, I'm sorry, I'm being stupid. You see, you might notice a little bit of a coincidence here. If we look at where process DMA-Q is called in Sonic 2, not this one though. Here we go. This is the level one. This is vint sub 8. Okay. So you scroll past some joypad code, this color related code, and you eventually get to the horizontal scroll buffer, the sprite table, then process DMA-Q, ignore the sound driver thingy, then start Z80. Keep this in mind. Now let's come to Sonic 1. VBlank 8. This is the level one. So we have read joypads, we have color related code, and then we have the scroll table, the sprite table, and start Z80. So as you can see, this code right here loads Sonic's graphics. So it seems to me when Sonic 2, the Sonic 2 developers added the DMA-Q, all they did was take this LAN and replace every instance of this code with it. So all we need to do is look up this son frame change thingy and replace it, any instance of it, with this. So there we go, just like Sonic 2. Then we look it up again. And here we go again. Now I hate to keep stopping and starting like this, but I do feel like I need to explain something really weird. I'm dead certain this is a bug. Okay? You notice how this is wrapped in stop Z80, wait Z80, and then start Z80. Now I've been programming for the Mega Drive for a long time, and I've heard, I know it's hearsay, but apparently, like, why is it stopping the Z80? Most people don't know, but others have argued on early versions of the Mega Drive, if you did a DMA transfer while the Z80 was running, you would corrupt the RAM. So there is some reason that Sonic Team did this. We're just not sure. But the weird thing is, Sonic's graphics get loaded while the Z80 is running. So, for the stability of your ROM hack, for it to work on even the earliest, buggiest Mega Drives, even if we are going to do this, we're still going to do what the Sonic 2 devs did, VBlank OA. Let's see how they did it, huh? VBlank OA, which may be 10 in this one? No. Oh, it's a special stage. Okay. Okay, no, this code looks different. But there are other places they do this. And I think in Sonic 2, they correct it and move the DMA-Q code, because this is a DMA, this is a DMA, I think, and this is a DMA. They all have to go between these two. So let's just keep going. Here's one that goes inside the Z80 stuff, so that's good. Here's another one that goes outside of it for some reason, and this appears to be the demo mode. So v-blank 16. Let's see what 16 does. Menu, okay. Well, would you look at that? As you can see, they learned from their mistake, apparently, and moved process DMAQ before the start Z80. Again, this is just weird stuff you learn after hacking for so many years. Yeah, hardware bugs, they are nasty little things. So, okay. And that's it. We've eliminated all of the old Sonic art loading code, and we've replaced it with the DMAQ code. But we're still not done. You might be thinking, wait, you just said there are two functions, which there are, and you don't need to call the first one right now, just the second. What do you mean there's stuff left to do? Well, Sonic 2 inlines some of this code, namely this bit. This code resets the DMAQ. Geez, how do I explain this one? Alright. The reason the game would do this, and do it so often and in so many weird bits of code, it's because it's a queue, right? And a queue will have a delay. So there is a chance that when the game loads or tries to do a DMAQ, there's a chance that later on it'll change. It'll decide it wants to do something else. But even though it's decided to do something else, the queue is still full of data, and the game will eventually pick up on it and perform a DMA transfer. Now, this actually isn't a theoretical bug. Sonic 2 forgets to do this weird code in one area, the continue screen, and it causes a bug. Now, in Sonic 2 Hilltop Zone, the background uses DMA transfers to load the cloud graphics. If you get a game over and then go to the continue menu, the lack of a DMAQ reset will cause the game to DMA one frame of animation of the clouds in the continue menu. This caused the graphics to get overwritten with cloud graphics. You can actually see this in, Some Call Me Johnny. He did a Let's Play of Sonic 2, the Sonic Jam version, as Tails. And yeah, if you watch that, he runs into it. Elliot gets a game over in Hilltop Zone, and it's corrupted. And even he's like, whoa, why the hell is it corrupted? It's because of this. So you want to avoid bugs like that in your hack, right? So we're going to be clever, and we're not going to make the mistake the Sonic 2 devs did. So we want this code. Now you might be thinking, all right, where is this though? It's at the start, kind of the start, of the various game modes, as we call them. Now, don't worry, it's not as bad as it seems. Go to the top of the ROM, scroll down. You'll find the code that the game runs when it turns on. It does the checksum, it initializes the hardware. You go past this. And eventually the Mega Drive will have finished setting itself up and it'll begin actually running. And here we can find the main game loop. This loop, the game will run forever. And what it does is decide what mode to run the game in. It'll either be the Sega menu, the title screen, the actual game, special stage, continue, and so on. Every single one of these bits of code, you should ideally reset the DMA queue at the beginning of every one. And this code's the same in Sonic 1. Scroll down, initialize the hardware, and we hit the main loop, and here we go. So for every single one of these, to prevent Sonic's graphics from being loaded, even after we've changed game mode, we want to reset the DMA queue every single time. So let's start with GM Sega. Now, there's a pattern. If we take a look at the inland code, you can see it always occurs after this weird looking code that's actually, if you follow the register, it's right into the VDP, the graphics chip. So always tends to occur after the VDP is reconfigured for this particular screen mode. So let's do that. So here's GM Sega. Oh look, it's configuring the VDP. So let's just put the code here. In Sonic 2 there's at least one area where this code is ran right after a call to clear screen. So if there's a clear screen call after VDP code, we're going to put it there. If there's no clear screen code, we just put it after the VDP code, and so on. So let's go back to that table. Here we go. GM title. Here's clear screen again. Alright. Now GM level. Here we go. Now while I'm doing this, I feel like I need to explain something because I don't know if I went over it well enough. You see, the point of the DMA queue is it's just a nice, mostly automated way to load graphics data from the ROM straight to VRAM. No need for, you know, loading it to a RAM buffer and then manually DMAing the RAM buffer. Yeah. So the point is we're bypassing that fixed size memory buffer, RAM buffer, by just not using a RAM buffer at all and just transferring straight from ROM to RAM. ROM to VRAM, sorry. So here we go, another call to clear screen. Is it me or is this code? No, never mind. Okay. And finally, credits. Okay, so we process the DMA queue, we reset it, but we don't occupy it. So now we can finally, if we built this and ran it, there shouldn't be any difference, nothing has changed, because we're not using the DMA queue yet. So we're now going to do the last bit. We're actually going to have to code a little something ourselves. So remember that load GFX thing? We're going to convert it so it does what Sonic 2 does. And I guess we could copy code from Sonic 2, but I can't be arsed. We're going to change it so instead of loading sprite data to this thing, we're just going to use the DMA queue. So I hope you know how to do assembly, because we're going to have to code some assembly. Oh Nelly. Right, so this is quite a complicated issue. Because while here we know every little thing the code is doing, we need to call QDMA transfer instead. And that function does other things. QDMA transfer. Like, a core concept in assembly is making sure your registers contain the values you want them to have. But if we take a look at QDMA transfer, it actually mutilates several registers. It will overwrite A1, it will overwrite D0, it will mutilate D3, D1, D2. And I think that's it, but yeah. It changes A1, D0, D1, D2, D3. So we cannot use A1, D0, D1, D2, D3 unless we reset them every single time we call QDMA transfer. So let's just insert our function call right now to get it out of the way. So after this code, A1, D0, D1, D2 and D3 will be corrupted and we cannot rely on what they used to contain anymore. Now, instead of just diving in and showing you what code's right, let's just go over what the code is doing, right? So, this is the DPLC script. It loads into A2 and it starts reading data from it. Now, D1 gets read here. And what D1 does, or what D1 is the number, it's a loop counter. It controls how many times this code loops. And it tends to be one number for each DMA transfer, shall we say, that needs to occur. Every block of data that needs loading to VRAM consecutively. But of course, it's D1. We need it preserved after this, so it can be ran here. So it can't be D1 anymore. Let's change it to a register that this code does not touch. Now, we can't use D7 because this code is object code. And in object code, you cannot use A0 or D7 unless you back them up and restore them. So for simplicity's sake, we're going to use D6. Every single D1 becomes a D6. And just like that, we've preserved the loop counter. It's safe, it won't be corrupted by this. So yeah. It then loads A3, which it uses as a destination to load the graphics to. But of course, we're not doing anything like that, so we can actually get rid of this. Now, you might remember this from the code we removed. Yeah, we don't need it anymore. Get rid of it. That brings us here. So again, we cannot preserve D0 through D3, but I don't think we need to. Because you can see, we run the code, hit this, loop back, and D2 is recalculated from scratch. So, okay. So we don't need to worry about data register preservation anymore. Or for now, I should say. But now we need to understand what these things even mean. What is D2? Well, yeah, okay. D2 is used as it's an offset. I actually don't think this is particularly important. It's used in the calculations, sure, but it's not used by QDMA transfer, so we can leave D2 completely alone. That eliminates a lot of code. So what's D0? Well, if you remember, last video we went and looked at the format on Sonic Retro's wiki, and what it tells you is, well, D0 is the upper 4 bits, which is the number of tiles to upload. So D0 is the number of tiles, which is fine, except it's in D0, because it's used as a loop counter, but, well, here's the thing. All these registers make sense. You know, D0 is D0, A1 is A1, that's fine for the old code. But QDMA transfer is different. If we look at its code, you have to give it values in registers. You have to feed it D0, D1, D2 and all that. Actually not D0, but you get my point. So how do you use QDMA transfer? Well, I don't think it actually says anywhere very useful disassembly, but you give it 3 values, I think. D1, D2, D3. D1 specifies the ROM address of the data you want to load. D2 specifies the destination VRAM address, and D3 specifies the length. So the length cannot be D0, it has to be D3. So let's quickly change that. Now, we're using QDMA transfer instead of this code, so we can get rid of it. And that reduces the work we have to do, so 10D0 to D3. Okay. So this right here is the ROM address. In the old code it had to be A0, but for QDMA transfer it has to be D1. Now address registers and data registers are a bit different, so we can just redo this code. Add I.L to D1. What am I talking about? Yeah. So we need it to be D1. So we could add @Sonic to D2, then move D2 to D1, or we just change all of D2 to D1. And that's good enough, right? So, what's the remaining one? The VRAM address, of course. Now, previously, I think the code was using A3 or something, which we ain't doing. Let's see. Now change, subtract. Yeah. So, let me rewind a bit. So here's that code we replaced with the DMA queue. It's this bit right here we're looking at. It loads from the RAM buffer this amount of data to this VRAM address. Well, we want that VRAM address. So back here we're going to move this to D2, which is the destination register. Now, this code here recalculates D1 and D3 every time. Every single time, yeah, it freshly recalculates these values. But there's an issue. We cannot recalculate D2. You see, DPLCs will load tiles from anywhere in Sonic's art file. When they get loaded to VRAM, they get put one after the other. So we need D2 to keep track of that. We need it to be preserved and survive a call to this, which again ruins D2. And we need to make sure to keep track. Every time we load graphics, we push this number forward by the number of tiles we loaded. So we can't have this be D2. We can have it be D6. No, sorry, D5. That'll be preserved. So D5 to D2? Not quite. Because again, we need to increment this thing every time we call this function, so we don't overwrite the date we just loaded, no, we write after it. But before we get to that, I think we need to address one more issue. D3 is a tile index, but like I said, there are multiple ways to refer to VRAM. It can be, yeah, tile index. It can be a byte address, so times 20, or it could be a word address, which is times 10. We need this to be times 10, not a tile index and not times 20, but times 10. So how do we do that? Well, I mean, you could use the multiply instruction, but that's slow. I think I'm just going to do this. Hang on a tick. Huh. Okay, look. The point of this is it shifts it to the right, thus discarding the 4 low bits. We described something like that in the last video. But to multiply it by 10, we have to shift it back to the left. So shifting it to the right and then back to the left will actually work, but it's kind of stupid. I think we can use an AND. Yeah, I think that's... well, actually not quite. Again, this is stuff you kind of won't know until you either bump into an error or you just happen to know these things. But not only do we need to, like... yeah, like this works, but there's an issue. D3, I think, is one value smaller than it should be. So if it was 0, it would copy one tile. But that won't work with the DMA queue. If you want to load one tile, you say load a tile. So we need to add to this. So, yeah, since one tile is 10, yeah, is an increment of 10, we're going to add 10, then perform an AND. Or better yet, as I say, I can't do it with a byte. Nah, I'm just taking a moment to think about this, making sure I'm not screwing the code up and have to debug it for the next 3 flipping minutes. I mean, this video is getting kind of long as it is. So yeah, we read the value, add 10 to it, and it. That should be okay. So this will transfer the first tile, but again, the point of this D5 and D2 register is to keep track of the destination. So when we transfer data, we need to add the length to the destination, so we point to the data after the data we just loaded, right? So you might think, oh, that's fine, after the transfer just add .w D3 to D5. No, that's bad, because QDMA transfer will destroy D3. Alright, so just do it before. And yeah, you're right, but again, well, while QDMA transfer wants D3 to be in times 10, it expects the destination to be in times 20, which is really weird. I think you can actually see the code for it right here. D2. Okay, I think that's what it does. It's kind of obscure. But yeah. So if this is times 20, and this is times 10, then we can't add it once, we have to add it twice. Yeah, this is weird and complicated, but I think we're now done. So to completely solidify it, let's go to the RAM file and get rid of the old buffer. We're also going to get rid of that one sprite change variable. There we go. Yeah, get rid of that. So now hopefully it will build and it will work. So we have a ROM right here. Let's see how good it is. Okay. Sonic seems to have loaded. It seems to be animating, his art seems to be loading, all without using that RAM buffer. The DMA queue is not working properly, as I can see. Alright. Just when I thought we were done. Okay, what am I doing wrong? So let's see. Add a byte and the value. Okay. Let's try that. Man. Yeah, I didn't have this problem when I did the practice run. I wonder what mistake I did. I know I wrote some code a little differently. I was hoping it wouldn't be a problem. So why is it jumping of all things causes it to corrupt? That is really weird. Alright, well, I'll get back to you when I figure out what the hell I'm doing wrong. Okay, I found it. I'm not totally sure why the hell this is an issue, but apparently it is. Alright, let's... So, add byte and AND. Okay, so... If we just spun this around, made it a byte, made it a word... That ought to fix it. Yeah, it's just some kind of numerical overflow thing. Like, the point is to take D3. Was it D3? Whatever it is, working. Look. The point is, yeah, to take A3, strip out the 4 lower bits, then add 10 to it. And, yeah, I was just getting that. I was getting some kind of edge case wrong. So there we go. Sonic is now working. If we bust out the VRAM viewer, again, need a flipping magnifying glass to see the darn thing, but there it is. There's no points graphics. Let's try and get Sonic to run up a slope. Alright, Now I think this is one of the glitchy frames. As you can see, Sonic has gone beyond his old RAM buffer limit and has now loaded his graphics into the portion of VRAM that used to be used by the points. And it is working fine. No longer showing numbers, and he's no longer missing chunks of him either. He is now completely correct, using a DMAQ code from Sonic 2. It's funny how often the need for the DMAQ comes up. That Sonic Retro hacking guide for adding the spin dash, it makes support the DMAQ. My videos on adding the elemental shields requires you port the DMAQ. Even just replaces Sonic's blooming sprite requires porting the DMAQ. It's amazing how Sonic won't go away without it. Anyway, so is that the end? Let's take a look at the to-do list. Wherever it is. There we go. Yeah, we've moved the points, we've ported the DMAQ to address the goofy sprite limit. Well then, I think, sans the colours being wrong here and there, that is the end of the problem. At the hour and 10 minutes mark, I really don't think you want to watch me edit a bunch of palette files. Okay then. So, just boot it one more time, give it a quick play test. So what have we done today? We've ported the DMAQ, overcome the sprite buffer limitation, corrected the badly converted mappings, we fixed the ending animation, we've fixed Sonic's diagonal frames. Yeah. So now this hack is much more complete. It's a miracle what some bug testing will dig up. But yeah, Sonic rotates properly, he loads his graphics properly, the ending is no longer stupid. Yeah, I believe that's all there is to this hack now, it's pretty much done. Strange how much of a rabbit hole it can be though, huh? Just like, ooh, I want to port Sonic Sprites, how hard can that be? And then it's like, today we're porting the DMAQ again. Just every time, I swear to God. So, yeah. It seems after an extra hour than I thought we'd need, we've finally ported the Sonic 3 Sonic to Sonic 1. If only we were hacking Sonic 2, huh? That thing already has a DMAQ, and all those bugs from part 1, I'm pretty sure were already fixed. So, oops. Alright, well. I can never tell how to end these videos. But, yeah. Ta-da!